All right, so this is just a quick tutorial on finding the equation of the regression line or line of best fit and the correlation coefficient from a set of data for two variables. So in this case, we have x and y. So the focus of these 6 sets of data is just to get the technical side right. We are not doing much analysis of actual real life scenarios right now. So we wouldn't be too sure if there's a correlation or a causation. We're just figuring out a few values. All right, so here we go. First thing we want to do is create a graph from these. So select the data, and as you normally would draw a graph, go to Insert and find Scatter Graph, which is over there. All right, so you could just do that for all 6 graphs if you like, just to get that done. Now what we want to do is just make this look a little bit more professional. So you can change the chart title, and in this case we don't know what variables they are, so we can just say correlation A, and then we want to call that y and call the x-axis x. So all this can be done in the add chart elements. So axis titles, horizontal is just x, make it a lowercase x, and likewise for the y. Okay. There we go. So we have everything ready now, and we must type correlation. There we go, fixed. Okay, so it's fairly easy to see that this will be quite a strong positive correlation, but we don't know the details in terms of the actual values involved. So the equation of the regression line is the equation of the straight line that best goes through here. We can see it's going to cut approximately at like 30 something, 40 something around there. But now we can actually put Excel to work and do it for us. So just select the chart again, go to add chart element, and go to trend line. Now in this case, it's linear because we're talking about a straight line. Now if you double click on the trend line or line of best fit, it gives you options here, and you can select display equation on chart. Okay, so you can just read it off there. Y equals 5.2606x plus 39.267. Now it says here round to 2 decimal places. Just round the gradient to 2 decimal places. So y equals 5.26x plus, and then just do something sensible. In this case, 39.3 or even 39 would be fine. So I'm going to say 39.3. That's perfectly fine. All right. So that then allows us to substitute in any value for x and get the corresponding y value. Whatever the variable is here, you'll get the corresponding value for that. Now, another thing we can do is find the correlation coefficient, the R value we call it, or Pearson's correlation coefficient. And that tells us how strongly correlated the data is. So what we need to do is we can do a formula. So you can choose any cell you like, so even down here, just so we can find the value, and then we'll pop it in here once we've rounded it to 1 decimal place. Now, for those who are unfamiliar with formulas in Excel, just start with equals, and then we want correlation. So just type cor, and it comes up, correl. All right, so there's your function. Correlation. Now, array 1 is the set of data 1, and array 2 set of data 2. So I'm going to just select, and then comma, and then select the other data, and that's it. Close the brackets and hit enter. And 0.99039532, etc., etc. So clearly it's very, very close to 1. So it's almost perfectly positive, perfect positive correlation. So in this case, a sensible rounding would not be 1 decimal place, it would actually be 2. So I'm going to say 0.99. All we need to do now is describe the correlation that exists. So in this case, as we've already said, strong or very strong positive correlation, and that's all you need to do there.